Hello, my name is Robert Elsenpeter. I'm the contributing writer to Dental Lab Products magazine. Today we're joined by Bob Cohen, president and co-founder of Custom Automated Prosthetics in Stoneham, Massachusetts. CAP provides outsourced manufacturing services to dental laboratories and specializes in digital dentistry. Bob, thanks very much for joining us today.
You're welcome, Robert. It's my pleasure to be here.
As we talked about, we're talking about tips to help dental labs ensure success, and we were interested in some of the products that you would recommend over at CAP.
Okay, well, when we start looking at products, there are a couple of different tracks that we can look at. There are those products that will help us grow our businesses, and those would be the products that our dental laboratories, or like, for instance, I have a laboratory, Advanced Dental Technologies, that we sell directly to dentists. And what's amazing about it is I think the product mix in this category has changed more in the last few years than it has in the previous 40 years. And I have been involved in this for about 40 years. And then, so there's that series of products. And then there's also a new series of products for dental laboratories which aid us in the manufacturing process of all of these products. And, specifically, it's all these digital components and elements that I think are important that I guess we can discuss more.
Okay. What are some of the digital things that are making a big impact on the industry these days?
Okay, so from a digital perspective, Robert, I actually did the other products first. Hold on a second.
Okay.
Okay. Okay, so from a digital perspective, it all starts with an open architect scanner and a best-in-class CAD software. There are numerous CAD systems and there are numerous different choices in this marketplace today. Recently we started looking at different open architect scanners and found that there are about 30 in the marketplace, which is an enormous selection. But primarily it looks to me today as though there's two primary open CAD design systems, that being 3Shape and exocad. I think both of those work reasonably well, or quite well. And they actually aid significantly in the efficiency of our dental laboratories, where for some time we had people designing restorations. It would take a long time with hand waxing, and now automating things just takes a few minutes. So it starts with that, and then there's other software integrations that go in the middle of this whole process as well, things like CAM, and also we have a software program that's unique to CAP, which is called CAPzilla, which fills in a lot of the automation that's in between these steps. In addition to that, then there's the output device. From an output device perspective, the most commonly used product in dental laboratories today is the milling machine. The milling machine has undergone dramatic improvements for dental laboratories over the last several years. We now have mills being manufactured that are absolutely product specific. So in other words, mill manufacturers are looking at like the lithium to silicate block and saying, what exactly do I need to mill a lithium to silicate block in a mill? And they're giving us exactly what's needed, no more, no less. It's the same thing for milling zirconia or milling metals and custom abutments. So the neat thing is that dental technology has been recognized by mill manufacturers, and all of these products are right for us and work efficiently, effectively, and predictably, which is a great thing. In addition to mills, the truly other output device that we're finding more and more common in dental laboratories are printers, 3D printers. For a long time, 3D printers have really only been a viable product for the larger laboratories, as the cost of 3D printing has been very, very expensive. We have more recently 3D systems just launched, for instance, the ProJet 1200. Which is a very affordable sub $10,000 printer that prints wax patterns for both pressing and casting. And these printers will produce about 10 units every hour, so it's a very efficient, accurate system. The parts remain, they maintain their shape long term, so it's not something where we're working with a material that has difficulties because it's changing shape after printing. In addition, the whole process is super cost effective. It really streamlines operations in the casting and pressing area. So that's another piece of equipment that I think will have strong growth in the future, in the near future.
Are these individual products that are really sort of on the leading edge, or is the industry headed that way? Is it just these particular products that you mentioned that are particularly great in these capacities, or are we seeing that across the board with all sorts of manufacturers?
Well, definitely within dental technology, this is definitely where we're headed. I would say probably throughout industry, although I'm not as up on other industrial processing as much as I am in the dental market. But without a doubt, within the dental market, we're seeing very specific machines developed for specific applications, which can help us reduce our costs, become more efficient, and do better work, better, faster, less expensive, less costly.
Okay. Is there a problem? Maybe problem isn't the best word, but is there a difference when these products are used by a smaller dental lab versus a larger dental lab? Is there a different process in terms of the production output from these machines?
There's really no difference for the smaller labs other than the fact that they may not get the same utilization from a piece of equipment. And so what's important for the small lab is that prior to purchase is that they evaluate the investment for return on investment. So they make sure that economically it's a viable investment for them. Whereas the larger laboratories today, obviously most of these machines work quite well from an ROI perspective. So that would be, really, if you're small, make sure you have enough work so that it is viable in your environment. Also, from a workflow perspective, I think it does change the workflow in your laboratory considerably. So whatever size lab you have to be open to the concept of reorganizing the workflow and how you manufacture, your whole manufacturing process. But in the end, once done, I think you will be more successful and more profitable. And I also think that CAD/CAM has a unique ability to not only increase your bottom line, but due to the vast number of new products that you can manufacture with CAD/CAM, you can increase your top line as well. So there's more products we can now sell into dental through CAD/CAM that we can't manufacture on an analog basis.
Okay. How do you maximize results with those CAD/CAM products? What advice would you give to a lab who may not be getting the best results out of their CAD/CAM solution?
Yeah, well, what we've done at CAP is a whole bunch of things. The first thing we did 5 years ago when we launched CAP, we started bringing in a lot of different CAD systems, and our initial thing was printing wax for pressing, and we were doing a lot of Emacs at the time. And one thing we didn't like, for instance, was the anatomical library found in the CAD systems we were working with, which at the time I think were Dental Wings and 3Shape. And also we had Lava as well, but there was no full contour in that at the time. So we didn't like the anatomical form, so we went ahead and we developed our own anatomical library, and we felt we would keep this for ourselves as a proprietary library. And it seems as though we do a lot of things at CAP that we do on a proprietary basis and decide later that maybe we should open this up to the industry, and pretty much everything we do we open up to the industry now. So we really developed this world-class library so laboratories can much more quickly, well, to start, when they get an initial proposal in their CAD, it's much more lifelike. And as a result of it starting out to be more lifelike, there's fewer mouse clicks to get to the end design, and the end design is superior. So having that is great. Then once we started milling, what happened was we found that our mills weren't giving us the detail of our design. So I think we were the first then to develop CAM strategies that included a 0.3 millimeter tool to go through and give us the definition of detail that was in our CAD design, and that helped us a lot. It's more commonly found now, this 0.3 millimeter tool in mills, and I think it's the way to go as far as giving us better results. So really it's about working with the company and working with solutions that are fully optimized, and it's not about buying a box, like if we buy a box of wax and we use it in a laboratory in an analog fashion. When laboratories buy digital solutions, they really want to look to make sure that the solution is fully optimized to be efficient and to give them the best in class product.
Okay. Getting very specific about one certain area, I'm curious about dental implants. Are there any specific products related to dental implants, producing a great implant that you would recommend?
Yeah, there's a whole bunch of new advancements in dental implants, and it kind of parallels the zirconia marketplace. Let's start with a product that we worked on development for well over a year, which is an IsoBridge, which is, I have to give Zircon-Zahn some credit because they were the first to develop what they call a pre-tau bridge. And the Iso is a very similar, not exactly the same, but a similar restoration in that we use full contour zirconia that becomes screw retained. Generally, most of these cases are full arch cases. And we see it as a replacement to the conventional hybrid restoration. As most of you know, a hybrid restoration is basically generally has a cast metal frame or a milled metal frame where you go ahead and process denture teeth to it with denture acrylics. And denture acrylics and denture teeth work fine as dentures, but the problems and the breakage that occurs when we create an angulose denture or screw retained denture is really way more than it should be. The numbers of failures and breakage in these cases is really not acceptable, especially when you look at how much money patients spend for these cases. So we now have replaced all of these acrylics and these acrylic materials that have flexural strengths of about 100 megapascals with zirconia. And the zirconia has a flexural strength of 1100 megapascals. So now we far exceeded the biting loads of patients. So this is one major breakthrough we've made. And it's also really nice in that it's not only stronger, but it's fully automatable, or 95% automatable. So the amount of labor we put into an IsoBridge is dramatically reduced from the competitive type products that have been around in the past. In addition to that, because it's made from a digital process, in the event of a problem, in the event of a remake, because we own the digital file to the case, a remake is really quite simple. It's really just pull up the old file, remill it, recenter it, and send it off to be replaced. So it saves us all around. It's good for the patient and it's good for us. So in addition to Iso, we also have a custom abutment technology has changed dramatically. Today, I think buying gold cylinders from implant manufacturers and adding wax to them and casting and having two different metals in them and then putting them on a hand milling machine and milling them out has been replaced with CAD/CAM custom abutments. And we can scan a model in about 5 minutes or less. We can design a custom abutment in less than 5 minutes, and we put a pre-machined blank in a mill that mills titanium, and the mill time is probably about 20 minutes. And there's a little bit of post-processing, and our custom abutments are done.
Okay.
Yeah, there's one more product we could talk about in implants, and that would be screw retained, like single tooth replacement is becoming more popular. Recent studies have indicated that the #1 failure in implant dentistry, the root cause is due to cement left behind when we cement a crown on top of an abutment. So by transitioning back to screw retained restorations, this eliminates the intraoral cementing, which eliminates the #1 cause of implant failure. So when we go ahead and do a CAD/CAM single tooth screw retained like zirconia crown, it's done very efficiently, very cost effectively, it can be an enormous profit center also for a dental laboratory. So those three products, when automated, I think are a wonderful addition to our product lines.
Okay, great. Well, Bob, those are really all the questions that I had. Was there anything else you wanted to touch on that I didn't think to bring up? Anything you'd like to add?
Yeah, I think there's a couple of things that I would add in here. Is that something else that CAD-CAM brings the dental laboratory is something that we call a CVB, or a CAD verification breach, which on all of our comprehensive cases, or our full arch cases, what we do is we go through our entire design process, and rather than milling it in our final restorative material, we mill it in PMMA, which is acrylic. And in doing so, what we do is we give the dentist and the patient the opportunity to try in our design. And so we can get all the critical feedback from the dentist and the patient if the design's correct. So we can determine hygiene, phonetics, aesthetics, occlusion, all functional parameters of a case before we do the final case. So very often dentists and laboratories struggle with final restorations going back and forth because they're really developing the treatment plan for the final restoration through the manufacturing process of the final restoration. So through the advent of the CAD verification bridge, we now have the ability to send out a plastic try-in bridge first, go through those internal processes of trying it in and evaluating it prior to fabrication of the final restoration. So that's something that can be done very simply. Once that's tried in and confirmed that it's correct, or if it needs minor changes, the minor changes are made note of. We can simply bring the old file back up onto our computer, make the small changes requested by the dentist, and go ahead and mill it in final material. So it creates more predictable end results.
Okay, great. Well, Bob, thank you very much for your time. I appreciate it.
Okay, Robert, thanks for having me.